Alright, boys and girls, welcome back to the drive-through as we continue our little voyage through Chapter 12, the final chapter of Algebra 2. This is inverse matrices and determinants. An inverse matrix is a matrix that we will multiply by to give us 1. Okay, or to give us the identity matrix. I should be more specific about that. The identity matrix. So, first I should say that the identity matrix for a 2 by 2 is 1, 0, 0, 1. If you multiply a 2 by 2 matrix times that matrix, you will get the original matrix. I guess let me show you that. If we do 1, 2, 3, 4 times 1, 0, 0, 1. Let's see, row by column. 1 times 1 plus 3 times 0. 1 times 1 plus 3 times 0 is 1. And now let's do this times that. 2 times 1 is 2 plus 4 times 0. And hopefully you're getting this now. If I do this times that, 1 times 0 is 0, plus 3 times 1 is 3. Nice. I thought I did it wrong, but I didn't. It was right the whole time. And then this times that. 2 times 0 is 0, plus 4 times 1 is 4. And look, we get the exact same answer. So, the identity matrix for a 3 by 3, ready for this? It's just that. And like you can see all the cool math, I think, but at least like the patterns, the fact that this might be applicable to like scheduling and things like that. So, we're moving on. How do we determine whether matrices are multiplicative inverses? So how do we determine whether these things are inverses? Well, A and B are inverses if AB equals the identity matrix, and you got to do it twice, it's a pain, if BA equals the identity. It's got to work both ways. So, AB equals 2 times 3 is 6, plus, let's see, row by column. 2 times 3 is 6, plus negative 5. And let's go here, times this, 15. And then plus negative 15, off to a good start. And now let's go this times that. 2 times 1 is negative 2. 1 times 2 is 2. And then this times that. 5 times negative 1 is negative 5. Plus 6. What do you get for that? 1, 0, 0, 1. I wish we could say that it is, but we also have to do BA. It matters. 3, negative 5, negative 1, 2, times 2, 1, 5, 3. All right, here we go. Row by column. 6 plus negative 5. Love it. Row by column. Negative 10 plus 10. So far, so good. Row by column. 3 minus 3. Row by column. Negative 5 plus 6. That equals 1, 0, 0, 1. Boom. Those are multiplicative inverses. Okay, evaluate the determinant. The determinant takes a matrix, which is technically two vectors. You guys don't know a whole lot about vectors yet, but you will in pre-calc. And we're going to take it into a scalar. So the determinant, how do you find the determinant of a 2 by 2 matrix? You do 4 times -8. Is it plus or minus? It's minus. That's what I thought. Minus 1 times -3. So it's -32 plus 3. It's -29. Now, the 3 by 3 is significantly more difficult, but it's really just 3 2 by 2 matrices. So here's how you do this. The determinant of this thing you take this number and multiply it by the determinant of this. So 1 times 3, 2, -1, 3. Okay? And then you add, again, let me make sure I'm doing this right. Yep. You add this number times that matrix. So 2 times 0, 3, 1, -1, or 0, 1, 3, -1. Not exactly sure how to read those. And then you take this number times that matrix. Oh, no. I screwed up the green one. Psych. Whoop. Whoop. Oh, shoot. Okay. Let's write it in blue. This is a 2, 3, -1. You do this number times this matrix. So 0, 1 was right. This should be a 2 and a 3. So think of it like covering up the whole row and multiplying. Once again, this was times this. The green one was times the matrix that didn't include the green number. And then the pink one will be times this matrix. So, and by the way, on the last one, this is what you guys are going to screw up on your quiz. You got to do the opposite. So that's minus a -2 times 0, 1, 3, -1. All right, so what did we do? We took the black number times this 2 by 2 black. We took the green number times this 2 by 2 green. And then we subtracted the pink number times this 2 by 2 pink. So eventually we are going to turn that into a plus. All right, so what is it? It's 1 times, and this is the determinant of this, and the determinant of that, and the determinant of this. So it's 1 times 9 minus -2 plus, remember this answer is going to be a scalar, it's just going to be a number, 2 times 0 minus 2 plus, it's a plus because it's minus a minus, 2 times 0 minus 3. So what is that? 1 times 11 is 11. 2 times -2 is -4. 2 times -3 is -6. The determinant is 1. Huh. Okay, moving on. Alright, as far as graphing calculator goes, just Google this. If you don't like what I just did about finding the determinant of a 3 by 3 matrix, then just do it in your calculator. There's a way you can do it. So that's where I'm going to go to the Google. Okay? Now, there's a cool little fact, I guess, that the area of a triangle is equal to 1/2 times the determinant of a 3 by 3 matrix defined by the triangle. That is, if you can write the triangle, add ones over here, which is so random, and then have this point be a point on the triangle, so 15, 7.5, and this point at Durham on the triangle, 5, 2.5, and then this point on the triangle, 0, 0. Okay, so the area of that triangle is going to be approximately 1/2 15 times 2.5 minus 0 plus 7.5 times 5 minus 0 minus 1 times 0 minus 0. So it's going to be 1/2 of 15 times 2.5. Let me get my calculator. Okay, so you're going to get 37.5 here. 7.5 times 5 plus 37.5 here. So half of that is 37.5. And that is the area of that triangle. Source, Google Maps. Uh-oh, the first ever Google Map reference from our book. This book must be from the late 90s. And what is the units on that? I don't know, because it's such a crappy copy of the map that I don't even know what the unit represents. So it's a completely useless map and problem. Sorry. But at least you learn how to use matrices. Last thing, determine whether the matrix has an inverse. If the inverse exists, find it. Well, first, how do you know if it has an inverse? If the determinant is not equal to 0, then the inverse exists. So, let's look at 19. The determinant of 3, -3, 4, 4 is 12 minus -12. So that's 24. So the determinant exists. So, if it exists, then the inverse, A inverse, the determinant, is 1 over 24, 1 over the determinant, times, watch, if it used to be A, B, C, D, then the inverse will be 1 over the determinant times, basically you flip everything and you do the opposite. No, you flip these. D becomes A and vice versa. You keep these here and subtract them, or do the opposite of them. Whew. The question is, am I going to ask you to memorize this? The answer is yes if you're an accelerated, no if you're not. So then what we will do, we go 4 here, 3 here, and then this will be a +3 and a -4. So the inverse of this would be 4/24, so 1/6, 3/24, 1/8, -1/6, and 1/8. That is your answer, and that is the video. I hope it helps. Sub 15 minutes. Boom!